Welcome to a video on level curves. The goals of this video are to graph the level curves of a given function, as well as recognize a function graphed using level curves. Level curves, sometimes called contour lines, are another way to represent a function z equals f of x, y. By letting z equal some constant, we obtain a single level curve. Remember, you can think of z as the height of the surface. So what we're doing is taking slices of the surface at different heights and then graphing those on the xy plane. If we do this for several values of c, we have a set of level curves to represent a given function. Now there are quite a few real-life examples of level curves, and we're going to take a quick look at these before we take a look at our own example. A pressure map can be represented using level curves, and the level curves are called isobars. A temperature map, which we often see on the news, represents a set of level curves called isotherms. And then an altitude map uses level curves to represent the height above sea level. Here's a pressure map. This may be difficult for you to read. However, each of these curves represents where the pressure is the same. However, each of these curves represents where the pressure would be the same. And in this region here, we can see that as we move toward the center of this region, the pressure gets higher. And over in this region, as we approach the center, the pressure gets lower. Here's a temperature map that we often see on the news. And again, every curve represents a region where the temperature would be the same. So in this map, we can see as we approach the center of this region here, the temperature is dropping. And as we move toward the outer region, the temperature is rising. And then lastly, this one's really hard to read, but you can see down the middle here, it looks like a river. And then there are a bunch of curves to the left and right of the river. And each curve here represents a different altitude. So you can kind of envision having this river in the middle and maybe some hills or mountains on each side. So as we approach the river, the altitude or the height above sea level would be dropping. Now for our purpose, if we take a look at the graph of z equals x squared plus y squared, we would have this surface generated here. It's a paraboloid. And the idea behind level curves is that we set the value of z to different values, and if we do that, you can notice we're going to have a circle where the radius is going to be different based upon the value of z. So looking at this graph here, you can see the circles that would be created with different values of z. And then to show the graph of the level curves, we'll look down on this looking only at the xy plane. Let's take a look at this using Maple. Again, here's the graph of our paraboloid. And then we set z equal to a variety of values, which we usually call c for constant. And it would create these black circles. And then if we rotate this and look down upon it on the xy plane, this would produce the graph of our level curves or contour lines. So the graph of the level curves would look like this, and again you can see the circles that were created by using different values of z. Let's take a look at another one of these. Here we have z equals x squared minus y squared. Here's the graph of the surface. If we set z equal to a variety of constant values, it would create several hyperbolas, as we see here in black, and you can think of this as slicing the surface at different heights based upon the value of z. And then if we look down on the xy plane, it would create this graph here, which is what we call our contour lines or our level curves. Let's take a look at it here. Again, here's our surface. And then if we set z equal to a variety of constants, it would create the hyperbolas that we see here in black. Again, what we're doing is really just slicing the surface at different heights. Then if we look down on the xy plane, as we see here, it would create the graph of the contour lines or the level curves. So here are the level curves in 3D, and then we graph them on the xy plane. It would look like this. Let's go ahead and try to create a contour map or a set of level curves for the given function f of xy equals x squared plus 2y squared. And we're given that we want c equal to 0, 2, 4, 6, and 8. And it's usually important to pick values of c where the difference is consistent. Notice here we're increasing c by 2 each time. So we're going to have to create 1, 2, 3, 4, 5 different level curves to create this contour map. First we're going to have c equal to 0. Remember, and these values of c represent the values that we'll replace z with. So if this is our function, it's really z equals x squared plus 2y squared. So when c is equal to 0, we're going to have 0 equals x squared plus 2y squared. And this one's not too exciting because the only solution to this is when x is 0 and y is 0. So really it's just a point at the origin. Now we'll let c equal 2. When c is 2, we'll have 2 equals x squared plus 2y squared. This is actually an ellipse. Let's go ahead and set it equal to 1 so we can determine our major and minor axes. So we'd have 1 equals x squared over 2 plus y squared. I'm going to put this over 1. So this is an ellipse centered at 0. And the major axis is horizontal. We have a squared equals 2 and b squared equals 1. So a would be the square root of 2, which is approximately 1.4, and b would be equal to 1. So we're going to move to the left and right of the origin 1.4 units, and above and below the origin 1 unit to create this ellipse. So 1.4 is approximately here, negative 1.4 is approximately here. We go up 1 and down 1. So now we can create the level curve when c is equal to 2. Now we'll just keep doing this for these additional values of c. So next we have c equals 4. So we're going to have 4 equals x squared plus 2y squared. Again, it's an ellipse. We'll divide everything by 4. So we're going to have 1 equals x squared over 4 plus, this would be y squared over 2. So again, we have a horizontal major axis, but now a is equal to 2, and b would be equal to the square root of 2, again, which is approximately 1.4. Let's go ahead and graph this ellipse. So now we'll go right and left 2 units, up and down 1.4 units. And now we'll sketch the second level curve. And now c is going to equal 6. So we'll have 6 equals x squared plus 2y squared. Divide by 6. So we'll have 1 equals x squared over 6 plus y squared over 3. So now we have a equals the square root of 6, which is approximately 2.4, and b would be the square root of 3, which is approximately 1.7. So now we'll move left and right approximately 2.4 units, and up and down approximately 1.7 units. And sketch our ellipse. And we have one more. Now we need to consider when c is equal to 8. Let's see if we can squeeze it in down here at the bottom. If c is equal to 8, that means z will be 8. So we'll have 8 equals x squared plus 2y squared divided by 8. That's going to give us 1 equals x squared over 8 plus y squared over 4. So a is the square root of 8, which is approximately 2.8. b is equal to square root of 4, or b is equal to 2. So to create the last level curve, we'll go left and right 2.8 units and up and down 2 units. And here's our last level curve. Let's go and take a look at this using some software. This would be the graph of the original surface. You can see it's an elliptical paraboloid. Here we see the level curves in 3D that we created with the different values of c. If we rotate this to look only at the xy plane, we can see the level curves that we created. I hope you found this video helpful.